Hi everyone, my name's Simon Brickett, and this is Things on Thursdays, which is a series where we are going to examine using Redis or Redis-related concepts with IoT devices. So the things in Things on Thursdays is Internet of Things. So recently in this series, we've been building something. Well, we started out by looking at the Redis protocol. So how do Redis clients talk to a Redis server? And we saw that that's implemented as a sort of fairly human-friendly string format that's pretty straightforward to implement. So we went ahead and built a Redis server with Python that pretends to be Redis. And we had that model a set to begin with. And then we moved that into the sort of hardware realm, so Internet of Things. And we moved it to this Raspberry Pi here, which is a Raspberry Pi Model 3. It could have been any model Raspberry Pi that has the 40-pin GPIOs, and we have this LED matrix attached to it that could be different colors. And if you saw last week's stream, what we did was we turned that into a Bloom filter, which is a sort of probabilistic data structure. And from that, we were then able to connect to it through Redis CLI. So Redis CLI thought our Python code was a real Redis server, albeit a very slow one. And we were able to do Bloom filter commands. And after that, we were then able to write some code in Node-Redis, a popular Redis client for Node.js, and run that. And that connected to our fake Raspberry Pi server and also thought it was Redis. So basically, we built a very, very slow Redis Bloom filter. Now, what I wanted to do sort of going forwards for the next few weeks. So there'll be this week, and there'll actually be a gap next week because I'm traveling, so I'm going to be unable to stream. But what I wanted to do was basically use something that is a bit less of a computer, and rather than running a Redis-like thing on it, use that as an input and maybe also an output for data that we're going to store in Redis in the cloud, and kind of see if we can build some sort of sensor-based device. So for that, we're going to need potentially multiple input devices that have sensors attached to them that capture, we have one device with one or more sensors attached to it. They capture different things. So maybe the temperature or the humidity or the ambient light in the room here, or something else. It might be a button press. Might be proximity. We'll see what sort of sensors we can get and what we can attach to these things. And I deliberately wanted to use something that is a bit less of a computer. So this thing here, the Raspberry Pi, is basically a small desktop computer. It runs an operating system. It runs a version of Debian Linux, or you can put other things on there. You can put Riscos on there if, like me, you're a child of the BBC Micro program. But most people run Linux on there, and that's kind of where all of the hardware support is aimed. So, that's a computer. It's quite a high-level Internet of Things thing. So what I wanted to do was take that back a bit and look at something that's more in the sort of connected microprocessor genre. So also from Raspberry Pi, they make these things, which is the Raspberry Pi Pico. So this and this are sort of the same family, but they're quite different things. So this thing here, the Pico, for a start, costs a lot less. Over here in the UK with the Wi-Fi option, which this one has, it costs you £6 to buy one of these. So I don't know what that is in US dollars these days, but let's say somewhere in the region of like $10 US, or whatever that translates to in your local currency unit. The other good thing about these things here is the Pico uses Raspberry Pi's own processor design, and these things are generally available in the supply chain at the minute. So if you don't have one, you can go out and buy one, or you can buy multiple. You can buy a 10-pack of them, and they're relatively easy to get hold of. Whereas at the moment, the computer-like Raspberry Pi is kind of difficult to get hold of. There's a lot of supply chain issues with those. There's an excellent account on Twitter called RPi Locator if you're looking for one. They basically look at all the websites around the world that sell them. They'll tell you when they're in stock at Adafruit or Pimeroni or the Pi Hut or one of many other places. Berry Base in, I think, Germany is another one they track. So they're tracking that globally. And if you want one, follow them on Twitter and keep an eye on it, because they're basically selling out as soon as they come in stock. But these Picos are available almost to order anytime you want them. I've not had any issues getting hold of a few of them for this project. And they also only really come in a couple of variants. There's like the one without the Wi-Fi and the one with the Wi-Fi. And you'll notice that the one I've got here is kind of a flat board. So these pins on the outside edge here, they're for connecting hardware to. They're general purpose I/O pins. Some of them are power. And this is flat. It doesn't have any headers on it. So you can get a version with headers soldered in for plugging things into, or you can solder stuff directly to this yourself. You save a little bit of money by not having the headers version. So what I'm going to do is just briefly talk about what we can do with the Pi Pico and what the programming options available to us are. And before we do that, I'm going to go ahead and share my desktop here. Here we go. So first up, this is the Raspberry Pi that we've been using before, the 3B. As I said before, it could be any model of Raspberry Pi with these sort of 40-pin headers here, because that's where you plug in a lot of the hardware. It just attaches directly to that. That's great, and it does what we want as a little computer. But what I wanted to do was taking a look at the rest of the Raspberry Pi range here. Come down here, and where are we? Here we go. We wanted a Raspberry Pi Pico. So the first thing that we see here is that this is not described as a computer. It's described as a board or a microcontroller board. And this is because the big difference between this and the regular Raspberry Pi is that this does not run an operating system per se. So this works more in the model if you're familiar with, say, an Arduino, where you drop some code or you upload some code to the board. It stores it in flash memory. And then what happens is there's like a known entry point into that code, and it just runs it on power on. And your code is essentially has to sit in a while true loop. So it has to run something forever while the board's on. And then you can just go put the board somewhere, embed it in something, turn it on, and it'll run your code. So this is a similar model to that. And there's two ways of programming this. So if we look at get started here, we'll see what this says. So we can program with either C, C++, which is similar to what you might have used with Arduino style devices, or we can program with MicroPython, which is what we're going to do today because it's a bit more approachable for more people. And to be honest, there's more chance that I'll get it right without too much debugging. The C++ SDK is kind of what's built into the device when you get it. It understands how to run that code. For MicroPython, we're going to have to install a runtime, and we are then going to have to connect to it. But the great thing is there's good tooling support, and we'll look at that. So what we're going to try and do is basically look at how to run code on one of these Pi Picos, and then how that can talk over the network to a Redis server using the Redis protocol when we don't have an operating system. So, we're not going to run a virtual environment and pip install things on this because we don't have an operating system. We can't run Node and do npm install. We don't have an operating system. So we're going to write some code that embeds a Redis client or something that looks like the basics of a Redis client in there. And we're going to get that off of the internet. People have written these before. And then we're going to connect that to a remote Redis instance. And we are going to basically start sending some information. And that's kind of the scope of today's stream, is get that loop set up so that we can have the Pi Pico running code that talks to a Redis instance in the cloud. We can look at that with Redis Insight and see what's landing in our Redis instance. And then what I wanted to do over the course of coming weeks is obviously these little devices, they're kind of all about the things you connect to them, because there's not a lot on here for input. Really, there's nothing. It's got one LED on here that you can program, so that's kind of an output device. It's got a reset button, and if we want anything else, we need to add sensors to it. So what I've got that we'll be exploring, and this will be new to me as well because I've not even opened it yet, is one of these things, which is, there's a standard for sensors called Grove, which is a standard way of attaching them easily without soldering. And this is a kit, I've actually got it here. This is a kit from a company called Seed Studio that gives us everything we need to play around with stuff. So we get a sound sensor, a rotary angle sensor, buttons, a small LCD display if we want to output some stuff. And then we get what's called a Grove shield for the Pi Pico. So what that's going to do, and I'll attach that because I think it's going to involve some soldering. So I'll do that off stream, because soldering live on stream, probably not the greatest television. So it'll turn these pins here in the Pico it'll put a carrier board on them so that we can plug the different sensors in easily without soldering. Then we can do a much more interactive demonstration of, let's run some sensor code and then change it to run something else, and maybe get another one of these up and running and use that display to show something, like show, I don't know, a running average of the temperature in the room or something, and have the two things talk over Wi-Fi through a central Redis instance. So that's the aim of where we're going today. So what we need to do is come back to here and let's take a look at this. So what is MicroPython? For all intents and purposes, it's Python for microcontrollers. It's obviously a bit limited because this class of hardware doesn't have much power, on purpose. It's quite a limited compute device. It draws not very many volts. It can run for a long time on batteries, and it's cheap. So, we can put these in things, we can program them, and some of the trade-off for that is that you don't get all programming language features, but that's okay because we're doing basic operations here. We're basically going to write something that sits in a while loop forever and reacts to events, or does something on a timer schedule, so like samples the temperature every 2 minutes or something, and then emits that out over the network to Redis. There's different ways that you can have these sorts of devices talk to things on the internet. So a popular one is to use an MQTT broker. So that's kind of a standard for messaging, and then have a server application read from the MQTT broker and do something with it. This is a Redis channel, so we're going to use Redis in that sort of role, which it's perfectly capable of doing. We're going to look at things like a Redis stream as a way of catching and buffering events from sensors. And then we might look at things like Redis time series as a way of making sense of numerical data over time. Or we might look at some of the other Redis data structures, depending on what we're doing with our application. So we might use Redis search to search sensor data over time. So if we want to find all the times when the temperature was within these values, then we can do that. So first off, what we need to do is this board here is fresh out of the box. It doesn't understand MicroPython yet. So what we need to do is set it up for that. And it's basically a drag and drop. So there's a MicroPython runtime file that you can download. I've already got it on my desktop. And what we do is we boot this up in a way that makes it look like a connected hard drive. And once we've got it up and running, we can then drag the MicroPython environment on it. And when it reboots, it'll boot and it'll look for some Python code to run. It won't find any. So what it'll do is it will drop into a MicroPython REPL, so read, execute, print, loop. I think that's what it stands for. And we can connect to that over a serial port, and there's tooling to help us with that. And then we can enter Python commands, or we can drop Python code on there and basically install it on the device and have it run on boot up. So that's kind of a lot of preamble, but what we're going to do is take this, and we are going to take this file that we've got here, mount this Pi Pico as a drive, and install MicroPython. So how you do that is I've got the micro USB cable connected to the laptop. You can use any micro USB cable as long as it's data as well as power. If you've got a power only one, then you're not going to get the data transfer. And I'm going to plug this in whilst holding the reset button down. And what you'll see is my Google Drive here has detected that a device was connected. I've told it a million times, not now, I'm not interested, but it still wants to do that. And what we should see here in the Finder now is that I have got a new device here called RPi RP2. That is my Pico, and it's functioning like a USB mass storage device at the minute. So this is in a mode for like dropping things on it. And what we're going to do is literally drop this MicroPython runtime on here. And what you'll see it do is once that file's transferred, it'll disconnect. It's copying. It'll disconnect and reboot. And there it goes. So it's disappeared as a drive. And then hopefully we'll be able to find it via a serial connection down that USB. And we will be able to connect to it and start to run Python on it. So how do we do that? Well, there's a few ways. And if you've used Pi Pico before, you'll see a lot of the documentation refers to using an IDE called Thonny, which is a really basic IDE, but it has some adaptations for talking to the Pi Pico. I actually like using VS Code for everything, and the VS Code marketplace is an amazing place. And there is, of course, an extension for working with these devices. So let's have a look at this. There's this Pico W Go extension. It's nothing to do with Golang. I guess it's just get going with the Pico W. It's actually for MicroPython. And what it's going to do is help us out with some auto-completion, but more importantly, it's going to connect to that REPL and allow us to run things directly on the Pi device, and also to push files down so that they're sort of installed and run on power on. So we can both sort of play with things and set them so that this thing's got it burned into its memory, and when we turn it on again, it'll just start running our code. So that's the extension. I've got it up and running here. And what I've got here in VS Code is let's close that out, is an empty Python file, an empty folder just containing a Python file. And what we're going to do is connect to our Pi Pico, try and run some REPL code, try and write some code, and ultimately get it talking to a Redis instance that we'll have to create somewhere in the cloud. So let's see how this goes for us. So this extension requires us to use this configure project task to start with. It drops a file inside here that basically just tells us that this is a project that uses a Raspberry Pi Pico. I don't think there's any other purpose to it. It's just it looks for that file name to know that it should activate itself inside here. And now we've got some extra tasks. So I've got Pico disconnected. Let's see if we can connect to it. What I've actually found is a couple of times when you do this, you have to disconnect it and reconnect it so that the extension sees it. But let's see. There we go. So it's actually doing something. So I'm surprised it's doing that. There we go. Right. So it's running some old code that I had there before. And now we've got to the MicroPython REPL. So the code that I had before, which actually shouldn't have been there, I should have wiped that, is no longer running. So we've now got this REPL here is running on this tiny device that's connected to the machine via a USB cable. So we can do basically Python stuff in here. So 2 plus 3, 5. Let's just make this a little bit bigger for the purposes of streaming. And we can do hello world and so on. So we've got a normal Python environment. And what is interesting about this device is, or MicroPython on this device, is that there's a machine class built into MicroPython. And that's where the magic for accessing the hardware is going to come in. So each of the I/O pins on this device, it's probably easier to look at a picture of here we go. So this is the one we've got over here on the right, but they're all essentially the same. This one's just got the Wi-Fi. So each of these numbered pins up and down the left and the right can be accessed in software, and we can configure them as either inputs or outputs, and then we can wait for events, or we can set them to have a certain voltage going out of them or not, and sensors and connected devices will react to that. So this is how we can program like real world stuff. So that's probably not something we'll get to today, but we'll just make sure we can get some data into Redis today. And as I say, I'll go and solder that Grove header up and we'll connect some sensors next time. So we've got a REPL here. We've got this terminal is basically connected to the serial terminal on that device. And there's no operating system here. It's like essentially the operating system is MicroPython. So we can't quit out of this to some shell prompt. That concept doesn't exist. So what we can do is take our file main.py and we can start doing stuff like writing some code and saving it. And then what this extension gives us is the option to run that file in the REPL there, or we can, where is it? Upload the project, which will push that file into the Pico, and you'll see when it's done that, it actually resets the Pico, so it's off and resetting. And then when it reboots, it will have printed that out to the REPL, but we can't see it because it basically happened too fast. So we're back at the REPL here. So we should be able to do something and get a response. But what we need to do is write some code that actually does something here. And we also need to connect to the network. So it's going to connect to the Wi-Fi here in the office. And it's going to talk to a cloud Redis. So we need a couple of things for this. We need a Wi-Fi connection. So we're going to have to manage that in our code, which is unlike what we did with the previous Raspberry Pi, where we configured the operating system to say, when you boot, go connect to Wi-Fi. We configured the Wi-Fi details in a config file for that. It's got nothing to do with our code. By the time the operating system's up and running, we've got a working network connection. In this case, we don't have that because there's essentially no operating system. So we've got to manage this sort of stuff in our code. So if we get rid of that from main.py and we go back here to the documentation, then let's have a look at software development. And I think also somewhere in here there is, well, let's have a look at Python because we're using Python. So Raspberry Pi are really good at providing documentation. Is this the one that I thought it was? So it's everything in this document for how to connect to this board from all the different things. They're going to talk about using Thonny. I'm using VS Code. And I don't think this is the doc that I thought it was going to be. So let's go find that. I think, got that somewhere. What we need to do is find some documentation about connecting to the internet. And I've got it somewhere. Well, I had it somewhere, but we can't find it. So let's try. You want to connect to the Wi-Fi with the Raspberry Pi Pico. So let's see how this goes. So there is somewhere on here that tells us how to do it. Am I going to end up back here again? Yeah, I'm going to end up back here again. So let's see, software development. No. Here we go, right. So under software development, I knew it was here somewhere. Connecting to the internet with a Raspberry Pi Pico W, which is what we've got. So that's what we want. So this takes us to another one of these Raspberry Pi documents that covers C and MicroPython. I guess this covers this subject separately because the original Pi Pico didn't have Wi-Fi capabilities, and this one does when it was added later. So I guess this is like an addendum or something. So let's see. Yep, we've got one of these devices. We don't need that. We just need some code that tells us how to connect to the network. Let's go back to the, was there an index? Here we go. Blah, 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 blah. Making HTTP requests, building HTTP servers, connecting to a wireless network. Here we go. So we need something like this. So it's a bit small, but basically we're going to import some libraries that are built into MicroPython. We're going to connect to a Wi-Fi network and wait for the status to be a sort of connected state. So what I'm going to do is start working in main.py here. And so we need import network and import time because we're going to have to wait for things. And then we are going to use the network interface. So we want network.wireless LAN and network.this type of wireless LAN station client. Okay. So you can always also make an access point out of this. So if you wanted to build a device that you can connect to its Wi-Fi, a bit like when you buy some of these connected devices to start with, and they expose their own Wi-Fi so that you can connect to it and then configure your actual Wi-Fi so it can connect to your device. So you could do a client or you could do an access point. We want a client here, so we're going to use that. We're going to turn wlan.active. So turn that on, and then we want wlan.connect, and it looks like that takes an SSID and a password. So what we're going to do is let's do secrets.wi-fi SSID and secrets.wi-fi password. So I'm going to make a secrets file that has those things in it, so we're not sharing those on the internet. And then what I need to do is while not wlan.isConnected. That seems like a strange function name to me because I thought Python was snake case, but it's all one word here, according to the documentation. And wlan.status is greater than or equal to 0. We're sort of waiting for it to establish the connection at this point. So we'll do connecting to the Wi-Fi, and then we'll sleep a little bit less than 1 second. And okay, so that should be it. So that should give us a network connection that we can then do something with. So and it looks like we can do something like print wlan.ifconfig, which I guess will be a bit like running the ifconfig command on Unix, and that will probably print out our IP address and stuff, so we should know if we've got something. So that'll do. And then what I'm going to do really quickly is add secrets.py, and in secrets.py, I need to set up Wi-Fi SSID and Wi-Fi password. So let's do that off screen here a minute. So let's do Wi-Fi SSID equals my Wi-Fi and Wi-Fi password equals, luckily I've got it to hand. Okay, so we've now got secrets.Wi-Fi ID, sorry, Wi-Fi SSID and secrets.Wi-Fi password. And let's make this a bit bigger again. And oh yeah, we kind of need to import secrets, right, as well. So let's do it in sort of alphabetical order. Okay. So we've now got something that hopefully will connect to the Wi-Fi and print our configuration when it does. So now we've got multiple files in our project. So we can't just right click this and do run the current file, because it won't push all of the other files down to the device. So we're just going to do upload project. It'll do that, reset the board, and then hopefully when the board comes back, we will see it starting to connect to my Wi-Fi and output something. So let's see. Connecting. No, we've still got the REPL. So interesting. Let's give this something to do so that it actually has something to keep it occupied after it's booted up while this is reconnecting. So let's do upload project. And see what happens when we reset the board. There we go. Right. So what was happening was it was actually happening faster than we could reconnect. And if you basically write code that doesn't loop on these devices, it'll just stop and nothing happens. So what we can see here now is we've got an IP address, and we've got some other information, which I guess is my router and the net mask and all of that stuff that we don't need. So that's working, so we can interrupt that. So we've now got a network connection, which is great. So we can do something with the network connection. We're going to need to send some data to Redis. So there's a couple of ways we could do that on this class of device. We could figure out what the REST protocol for our command looks like. So all of that stuff that we looked at in previous streams, or we could go get a Redis client for this sort of device, the MicroPython environment. And that's the option we're going to take. So someone else has done the work to handle the REST protocol and wrapped it up in a nice Python client for us. And then the question is, how do you go about adding that to a project on this sort of device? So let's first take a look at it. So over here, we've got a Redis client here called Pico Redis that I actually found whilst searching for these things on the internet. There's a couple of other clients available for MicroPython, but I like this one because it's pretty basic. It's in a single file, and the way that it works is it kind of supports all the Redis commands because it just has a generic function for sending things to Redis. So the command, the client here is entirely contained in this one file. So all we need to do to put this in our project is literally paste this into our project in its own file, and then we can import it and start using it. So there's a Redis, somewhere there's a Redis class here that when we initialize it, we can tell it where Redis is. And then we basically have this function here that acts like all of the commands and just sends something to Redis. And it doesn't do very much with the response. So it doesn't parse it out into like Python dictionaries or other things. It just leaves it as whatever bytes come back from Redis, but that's fine. On this class of device, we're not too worried about that. And in any case, this device we're going to use as a sort of stream producer. So it's going to push things into Redis and it doesn't really care about what happens after that. So this will be fine. So what I'm going to do is grab all of this code here. Let's take that. And I am going to add a new thing here, and we're going to call it Pico Redis. Oops. Pico Redis.py, and we're going to paste that into there and just save it so we can kind of forget about that class now. So that's our Redis client integrated into our project. We don't have a package manager on this class of device, so that's what you get. Now, what else do we need to do? So now we've got a network connection. We should basically do something like in this while true loop, we need to do something like, well, actually up here. Now we've got a network connection. We should first connect to Redis, right? That would be good. And then once we've connected to Redis in our while true loop, what we want to do is add some value to a Redis stream. So we can add some value to a Redis stream and see how that goes. And that's kind of like the target for today's live stream, is to get this little tiny device to be able to talk to Redis in the cloud somewhere and do something more meaningful than just this. So let's save that out. So, okay, connect to Redis. So we need an instance of Redis. We need that to be somewhere that this device can see it. So it would probably be a good idea to put it in the cloud. And what I'm going to do is set that up really quickly. So if we go to redis.com here, and you can go to try free and sign up. I'm already signed up, so I'm going to log in here, and let's see if I can remember my credentials. Yay. So I'm logged in, and when you sign up, you can create this thing called a 30 megabyte subscription that is free. It's feature complete Redis with all the Redis Stack modules, and we'll use some of those in a future stream. And basically the limitation is the size. So you get 30 megs worth of RAM to store your stuff in, and that should be fine for playing around with these devices and quite a lot of other things. In fact, you could run a Redis stream in here forever, because you can trim a Redis stream by date or by number of entries. So you could have a data structure that things are storing things in, and other things are reading them out, and which kind of looks after its own size as well. But that's maybe something for a future stream. So I'm going to do new database here. I am going to call it Pico project. That's just an arbitrary name. We are going to have a Redis Stack database because we want to use maybe time series or some of the other Stack features. We don't want to mess with any of these things. We do want a password, and I'll just, whoops, expose that. So that's not a good idea, is it? Behaves throwaway database. So we will set a password. In fact, I'll just go and change that to that and just write that down really quickly because I'm going to need it. So those of you looking at the live stream, that's not the password anymore. Okay, so that's about it. So we can just hit activate here. And what you'll see is it's off building this database for us. And when it's done, we'll get an endpoint here that we can connect to. And that is something that we're going to need to remember. So let's just go back to our code here. So let's make some constants up here for Redis host and Redis port, which is going to be a number. And then in secrets, I will store the Redis password. So let's go back here. Okay, we're green. So we've now got a database. So we've got a host and a port here. So let's copy that. Drop it in our code. So I want a Redis host there, and I want 115.65 was that? I think it was that. Let's check. Yeah, 115.65. So we are going to use those at some point. And here's our database. So it's set up and I've got the password. I can copy that. And first thing we should do is make sure that this database is actually set up and has nothing in it, which is the expected state. So I'm going to use a tool here called Redis Insight, which is a graphical tool for managing Redis instances. So you can see I've got a couple configured already. I'm going to add a new one to this database that we just created. So add Redis database, and I'm going to need the host and the password and stuff. So let's get that. So if I paste that in here, this understands how to parse that out. So I've got a host and a port, and we'll call it something here in Insight. I'll call it Pico project as well. And we're not using the username because we're using the default username. And then I need to take that password, which was down here somewhere, copy that, and paste that in there, add Redis database. Okay, so we've got a new one here called Pico project now. So let's also zoom in a little bit on Insight so that you can see it a little better. So we've got a database called Pico project here. It's got all of these modules installed. So search, JSON, graph, time series, and Bloom over and above the standard Redis functionality. So streams that we're going to use today is built into all Redis instances. So we've got that anyway. And let's click here and see what we've got. We've got no keys to display. So we have an empty Redis database in the cloud. And what's going to happen is as we put stuff in here, it's going to appear in this key browser, and we will be able to hopefully watch the Pico push stuff into Redis in real time. So a quick demo of that. If I fire this up, I've got a normal Redis CLI connected to that database. And if I change the refresh here to auto refresh, hopefully we'll see a key get created up here in the key browser view when I do something like set hello world and give it a couple of seconds. And what we should see is here we go. I've got the wrong view there. I was looking at the tree. So hello has been set to the value world, and then we can trash it. And now we are back to an empty database again. So what we're going to want to do with our Pico is, and potentially multiple of them, is have them write data into a stream. So let's just look at that really quickly. I've got an empty database here. I am going to add something to a Redis stream. And one of the cool things about that is that it creates the stream for me. So I don't have to like pre-dimension or say to Redis, this is going to be a stream. I'll just add something to it. So let's do xadd. And let's do Pico project my stream. So we'll call that's the key we're going to use. So we'll try and keep our keys tidy and use say Pico project as a prefix. And this is a stream, so I've called it my stream. And then I have to give it an ID. So stream entries have IDs. They're timestamps by default. So we can say to Redis using asterisk here, go create that ID. So whenever it hits Redis, it'll get the server's timestamp. This is good for like little devices like the Pico here because there's no real-time clock on those by default. So if we wanted to know when something happened, we'll just use the time when it hit Redis as when it happened. So obviously that's the time when it happened plus a bit of network latency to get to Redis, but it's good enough. And then we can add fields and values in here. So let's do name, Simon, location, UK, for example. The stream doesn't actually care what this is. There's no schema defined here. The next entry could have completely different names and values. So when I enter that, what we see is I've got a stream ID back. So that's a timestamp, and it's a number as well. So Redis is actually fast enough that inside this millisecond precision timestamp, it could have, in theory, received multiple xadd commands. And if they add to the same stream, we get 98-1-2, etc. And the nice thing about Insight is I can then click on this, and let's close my CLI for a minute. And you'll see that I've got a table here of everything that went into that stream and the entry ID. And I can also turn on the auto refresh here. And what will happen is it kind of polls this value now. And if we put something else in there, you can expect it to appear. So let's get that command again and add somebody else. So let's add Justin and do location USA. I've added that, and you'll see it turns up in the table on the right. So Insight's a really good tool for watching these sorts of live data systems, and hopefully we can get some stuff that's actually generated by the Pico into here by the end of this stream. So what I'm going to do is delete this. So we've got an empty Redis again, and get rid of the CLI to give us some space. And let's go back to our code. So I've got the Redis host and the Redis port here. I'm going to need to connect to the Redis client. And if you're familiar with other Redis clients, what happens with things like Redis Pi is you just instantiate an instance of Redis and pass it in some named parameters. So we're going to do that. So I'm going to need to do something like from Pico Redis import Redis. So we want the Redis client. Then down here, we need to connect to Redis. So let's do something like, I think it's Redis. And then here we go. So we need a host and a port. And actually, our Redis, because it's exposed to the internet, has also got a password for security reasons. So we're going to need to authenticate to it. And this constructor doesn't seem to support that, but we'll see how we can get around that. So we can do host equals Redis host, port equals Redis port. So that should give us something that is then at least talking to our remote Redis instance. Now, save that. So our Redis instance has this password here, and we're using the default user. So that's kind of like one user for all of Redis. You can set up what's called access control in Redis and set up separate users with different permissions. So we might in future look at setting up these devices that are just going to push data into Redis to only be allowed to say run the X add and maybe a couple of other commands, and to only be allowed to modify a certain part of the key space. But as we're developing this, we're just going to use sort of root level permissions for everybody. For right now, we'll have a single user. So the question is, how do we log into that? So let's go back here and do redis.io/commands. So some clients take a password in the constructor and they'll handle this for us. We need, I think it's a server management command. Lots of commands here about access control users. And nope, it's not a server management command. It's a something else. Let's just search for it. We need the auth command. There we go. Authenticate to the server. So the first command we need to run is auth, and then optionally a username and a password. We don't have a username as such. We're using the default user, so we could, I guess, say auth default and then the password, but we're just going to use the password. So let's do, we need to do then r dot, and basically the way this works is we call commands against this, and it's, or we call functions against this, and it turns these into a Redis command and just passes the arguments. So we then want secrets dot Redis password. Hopefully that will work. And then, of course, what I need to do is quickly go out of Redis password to secrets here. So let's set that up, and let's get a copy of that password from here. And we're probably done with our auth command now. Okay, so our code now looks like this. We're calling auth and we're passing in the password, and then we're going to do something. So let's see what we want to do. So we don't need to know if we've got Wi-Fi anymore. let's do something a bit more often than 5 seconds, so maybe every 2 seconds. And what we're going to do is do r.xadd, so modeling that Redis command that we had in the CLI. And what we're going to do is, first parameter is the key name. So let's call our key Pico project colon. What do we want here? So we're just putting arbitrary data in here for now. So let's say we'll have it at, let's not do that. Let's just call it incoming, because we don't know what sort of data we're going to send yet. We'll redesign this later when we've got a sensor connected. So Pico project.incoming, colon incoming is the name of our stream. And then we want to say, what's the ID that we want to add to the stream? And we'll tell Redis just use the server clock for that, which is great because these devices don't have a clock. And then we can just add name value pairs for like the flat map of things we want to store. So let's do device ID, and we'll arbitrarily call this device number 1. And maybe we should do something different with that in future. Like we could perhaps use the IP address or something, but that could change. So we probably do want a device ID. So if this was, for example, logging temperatures, then we would want it to always be device ID 1, and we'd need to know where it was. So if it was in like a given room in the house or something. So we'll use hard-coded device IDs for now. And then we'll just have something called data, and we'll say hello for now or something. No, actually, that's not very interesting, is it? So let's do something like, and then we'll do some sort of count. And obviously this will eventually run off the size of an integer, so it's not great. But I've got some code that will then basically run forever. So let's see, we can do xadd to Pi project incoming. We're going to say star. I want Redis to set the ID, which is great because we don't have a clock here on the Pico. We want to use 2 name value pairs, so device ID of 1 and data of whatever the string value of n currently is. Go to sleep for a while, so I simulate doing some work or just waiting to sample the temperature or whatever we're looking at again, and then increment the number and do the whole thing again. So let's see if this is going to work. It's kind of the time where the rubber hits the road. So let us see if we can run this on the device and what happens. So down here, I've got my terminal. I'm going to want to upload the project, and I've just realized we probably should have put some sort of output in here. So we'll have a look at that in a minute. But in theory, there's not a lot going on to look at here. But if this is working, then we should, yay, look, we should have data in Redis. So over here, we've got connections timed out because the thing's busy. It can't run the console at the minute. It's running out tight loop code. So we've got Pi project incoming. And here's all of this data that it's written. So it's already written 8 of them. If we turn on the auto refresh here, what we should see is, oh, there we go. It's up to 12 now, 13, 14. And Redis is giving it these timestamps that Redis Insight is parsing out for me into my local time. So it's 11:25 here in the UK. So it looks like we've succeeded with like this much code to get a device that costs, £6, sort of $8, $10, whatever that is these days, to talk to Redis. And we've got a self-contained project that has our own Redis client in here that we got from, where did we get it from? We got it from GitHub user Spotlight Kid, who very kindly wrote a Redis client for MicroPython that seems to be working nicely. I'll reach out to them and say hello and thanks for doing this. It's MIT licensed, so it looks like you can use it in your own projects. And it's, it's basically doing the thing. So one optimization we could add here is capture the response from this and print it out so we can maybe see it on the terminal. So let's try that out. Let's do what you get back is a stream ID, that, and then we can just print stream ID out. And let's see if uploading the project helps. Oh, we need to. There we go. Let's let it connect a minute. Let's try again. Oh, there we go. Okay. So I uploaded the project, connecting to Wi-Fi. Okay, so we're back and logging stuff. So let's see what happens now. Hopefully, once it's connected to the Wi-Fi, which does take a little while on these devices sometimes. There we go. So what we start to see now is these are the stream entries. This is a millisecond precision timestamp, and then a dash, and then a sequence number in case we have lots. And what we should see is over here, as this is outputting them, then over here, what we should see is obviously the number reset because we rebooted the device and we have no persistent storage for that number. So what we should see is these IDs here start to match this here. Okay, so what we've done here is we've created a device that whenever I turn it on, it doesn't have to be connected to my laptop anymore. This just has to be connected to some power source and a micro USB, or we could solder in a power source that's a battery or something. Then it's just pushing data to that cloud Redis that we created for free in what, how many is that? 29 lines of Python, which is not bad at all. So what we're going to do in future iterations of things on Thursdays is start working our way through this box of sensors, some of which are inputs and some of which are outputs. And I actually have multiple of the Pi Pico Ws, so we'll use those. And we'll aim to generate some sort of thing where we've got a small network of sensors that input something to Redis, have Redis do some sort of, or code that's talking to Redis, do some sort of work on that data and manage it so we don't have a stream that we have at the moment, which is just going to grow forever and will eventually overcome Redis. And then we'll use another Pico W connected to some sort of display to receive some sort of output or calculated value like a running average or something, and display it somewhere on a sensor on a little screen. So we can have sensors that we put around the place, and we can have an output, and we can have them all talking through Redis. So that was where we got to today. So I am pretty pleased with that. So what I'm going to do now is here's the device. I'm literally going to pull the plug, which will stop it running. And what we should see is that no more entries turn up in this stream here. And we can see in here that we've generated 108 entries in the stream, and it got up to 54 in the count. And these are all the timestamps, and they're all from device ID 1. So that's kind of as we'd expect. So what I'll do after this stream sometime later today is create a repo with this code in it and share it. And I'll update the YouTube video description with that. But the other place that I'll update, and you can always talk to us, is the Redis Discord here. So we have a Discord that you can join right here. And everything in here is, well, we're kind of like mostly about Redis, but we'd love to talk to you about things that you're doing with these sorts of things. So I have got in here somewhere an Internet of Things channel. So if you're interested in this sort of content, come join us in there. You can chat with me and the rest of the developer relations team. But also there's several thousand people in the community that have all sorts of different experience and do lots and lots of different projects, with Redis, with different languages. So we have people that code in Golang, people that do Java, .NET, Node.js, etc. So if you're interested in that, go check out Discord. if you would like to see when we are doing other things, let's go to the Redis Live page. So developer Redis.com, Redis-Live, we have our events page. So here you can see what's coming up. So I'm actually back on stream later today with Sue, Savannah, and Justin, and we're going to be holding Redis University office hours. So Redis University is our online training and courses thing. So if we go to university.redis.com here and we go to courses, these are all the courses you can sign up for. We have 9 of them. And in this series of streams, we're going to be using material probably from this one, the Redis Streams course, which discusses the Redis Streams data type that you saw me use today. And also probably this one, because we can put data in a stream and we can get it out by time basis. So we can say, you know, what data was recorded by this sensor between these 2 timestamps. But if we start to add Redis search and Redis JSON, we can then store complicated data that isn't just a flat map in other data structures in Redis, refer to those in the stream, and then search over them. So we can, you know, build an interface that would tell us, like, give me everything from sensor 1 between this time and this time where the temperature was above like 20 Celsius or something like that, if that's what it's recording. So we'll start to explore these concepts as this stream goes further. And I'd recommend you check out Redis University and, you know, sign up for a course. They're all free. They're online. You can earn a certificate of completion that you can share with everybody on LinkedIn. So yeah, that was it for today. I am, as I say, really pleased that we managed to get a pretty much box fresh device, install a runtime on it, get a Redis client, write some code, and have it actually deliver data into the cloud where other things can use it. So I will not be back next Thursday. I have some travel on that means I'm unable to stream. So the next stream after this will be a week on Thursday. And if you want to check when that is and just keep up with all of our stuff, as I say, go here to developerredis.com, Redis-Live, and you can keep up with everything that we've got going on here in the DevRel team. So I might see some of you later. I'll be back on stream, as I say, with some of the other team members doing office hours. And then we have other stuff coming up on Friday. I believe we've got Guy live streaming, and I'll be back with, again, Sue, Savannah, and Justin. And we'll be looking at the week in Discord. So if people have asked us interesting Redis questions in Discord, sign up there. We will look at those and we will go through why it's an interesting question, what the pros and cons of some answers are, and talk through how we answered it. And if you want to ask one of those questions, don't be afraid to ask something that you might think, oh no, they'll show me on stream and this is a silly question. There are no silly questions, and we do anonymize all of the data. So we won't show you a username. We'll just answer your question for you and give you some options. So yeah, join us for that tomorrow if you're interested. But for now, hope you have a great rest of your day wherever you are. It's still just about morning here in the UK. So it's time to go refill the coffee cup and see what else is going on. Thanks, everybody. Bye.